Hello and welcome. We're going to do the last aiming for a grade 9 paper right before the exam on Friday, which is pretty damn exciting. Again, I'll leave the link to this paper in the description if you'd like to either A, attempt it before you watch the video, or B, you want to attempt it a bit later just to see if you can kind of get the same answers as I did. But all of these answers are indeed checked to be correct, so it should all be totally fine. But if you have any questions about methods or anything, then please just let me know in the comments and I will of course get back to you. But let's get started. So we have to find the exact value of the fourth root of 81 times 10 to the 8. And of course the key thing here is to remember that you can treat this entirely separately. So you can have 81 here and then times, and then we'll make that also a fourth root 10 to the 8. So you can do them completely separately and it's completely fine, which is why standard form is so good. So what's the fourth root of 81? Again, knowing this, it's a bit tricky, but go up in like ones, right? So 1 to the power of 4 is 1, 2 to the power of 4, that's 2 times 2 is 4, times 2 again is 8, times 2 is 16, so it's not that. 3, well 3 times 3 is 9, times 3 again is 27, times 3 again is indeed 81, so it's 3. Or you can just kind of, remember it. And then what happens when you take the fourth root of a power? So what happens to the indices? Well, you actually divide by the indice. So you're going to have times 10 to the power of 8 divided by 4, which is of course 2. And it doesn't say to give your answer as a standard form or as kind of a normal number, so we can write it in both ways and that should be totally fine for the exam. 64 to the power of minus a half, so I personally do it in order, so I do the minus first, so that means it's 1 over 64 to the power of a half. And if you remember, when you have a power of a half, that means you're taking the square root. And what's the square root of 64? That is 1 over 8. Okay. A question I do get sometimes asked is kind of, do I need to put the plus minus when it's square root? You don't need to do that, okay? It's only when we're actually solving an equation that we care about that. Writing this as a single power of 3, so all we need to do is make all of it base 3. So we have 3 here, so 3 to the power of n stays exactly the same. But how can I write 9 in terms of 3? Well, I can write it as 3 squared. So that becomes 3 squared to the power of n minus 1. And then what happens when you have a bracket, so a power, bracket to the power of, then you times, okay? So you have 3 to the power of n over 3 to the power of 2n minus 2 because you times the powers together, which now we're subtracting. We've got 3 to the power of n minus 2n minus 2. So in short, that would become 3 to the power of n minus 2n would be minus n, and then minus 2 would be plus 2, okay? Or you can write it as 2 minus n. The order doesn't actually matter for that case. This question is a recurring decimal to fraction question. And here is Ted's method. So he has x is 0.43 recurring. And he does 10x. Okay, not too bad. But then he does 10x minus x. And he does this. So we have to evaluate his method. Well, the whole point of doing this x and then 10x or 100x is that we can minus it and we get rid of the recurring decimal, right? So ideally we want to have another number where the recurring decimal is still 4,3 recurring, because then they'll cancel perfectly. If you look at his method, we have 3, 4 recurring and 4, 3 recurring, which means the recurring decimal will not cancel out. So the recurring decimal will not cancel. Decimal will not cancel. So he can't change into a fraction. If you'd like, you can actually say what he's supposed to do. And in order to make the kind of decimal recurring, as if he times it by 100. So if he does 100x, you can see that will become 4,3 and then dot 4,3 again. So then that's what he should actually be having. For question 3, it's solving a quadratic, but remember, to solve quadratics we need to make sure that it equals 0. So we want to move everything over to one side. Now the question is, what side do we want to move it over to? Well, I prefer to have a positive x squared. Ideally, I want nothing in front of x squared, because then I can factorize really quickly. So I want to move everything over to the left-hand side, so that becomes minus 5x minus 24. And then I'm thinking of two numbers that times to minus 24 and add to minus 5. Well, if you think about it, because it is equal to a minus 24 when you times it, we have one positive and one negative number. So what I'm thinking is minus 8 and plus 3 would be the ones that work. So we have x, and that should equal 0. I should probably do that. So we have x minus 8, x plus 3, equals 0, which means x is equal to 8 and x is equal to minus 3. For 3 marks, nice and quick question, hopefully shouldn't be too bad. So for this question, we get shown a cube with edges of lengths x and a sphere of radius 3 centimeters. They give us the surface area of a sphere formula, which is quite nice. And it says the surface area of the cube is equal to the surface area of the sphere. Show that x is equal to the square root of k pi, where k and pi are both in the square root. So, if we think about it, how do you work out the surface area of a cube? Well, you work out the area of its face. And remember, since it's a cube, all of these sides are x, right? So, the front face is just x squared. Now, another thing about the cube is since all of the lengths are the same, it means all of the faces are identical. So how many faces do we have? We have 1, 2, 3, 4, 5, 6. So in total, the surface area of the cube is just going to be 6x squared. And then we have to just equate that to 4 pi r squared. So 4 pi, and the radius it tells me is 3 squared. So let's expand that bracket. So 6x squared is equal to 3 squared is going to be 9. 9 times 4 would give me 36 pi. Now I'm going to divide both sides by 6 because I want to get x equals. So I'm going to basically rearrange for x. That gives me x squared equals 6 pi. And then we're going to square root both sides and we get x is equal to the square root of 6 pi. Just like that. So k in this case is 6. It has to be an integer and k is indeed an integer. Now we have everyone's least favourite questions probably. Well, maybe not. But you have to make f the subject of the formula, and if you look, there's actually 2 lots of f. So I'm going to show you the kind of order in which I rearrange, okay? The first thing I want to do is get rid of any fractions, and then I want to expand any brackets. So if I want to get rid of a fraction, you can get rid of any fraction this way. You times it by its denominator. So I'm going to times by f minus 4. And because I've done that to the right-hand side, I need to do that to the left-hand side as well. So that becomes d f minus 4 equals 3, 1 minus f. So now I have no fractions, cool, but I have a bunch of brackets. So now expand the brackets, okay? So df minus 4d equals 3 minus 3f, okay? So that's my order. Whenever I do any kind of algebra, I get rid of fractions and then I get rid of brackets, okay? Especially when it's making the subject. Now, the problem here is that we have 2 lots of f and we want to make f the subject. So we just want f equals. So here's what you do once you get to this stage. You move all of the f's to one side and everything else to the other side. So any term that has an f in it, we want on the either left or right side. I'm going to move it to the left because then all of my f terms are actually positive, right? So I'm going to add 3f to both sides. So I put them all on the left-hand side. We get df plus 3f minus 4d equals 3. And now we want to put any term that hasn't got an f on the other side. So in this case, the right-hand side. So I'm going to plus 4d to both sides. So that gives me df plus 3f is equal to 3 plus 4d. Okay? So now I've got all of the f's on one side. I've got everything else on the other side. I can now factorize out an f. So we get f is equal to, open bracket, d plus 3 equals 3 plus 4d. And then I can move that entire bracket to the right-hand side and it'll be underneath the 3 plus 4d. So that becomes f is equal to 3 plus 4d over d plus 3. And that is our final answer. If you get like 4d plus 3 over 3 plus d or something, that's completely fine as well, of course. It doesn't matter as long as it's equivalent to that. So any equivalent form is okay. And in this question, we have a capture-recapture question. So these actually don't come up that often, but in my opinion, they're very nice. Well, 4 markers in total. So hopefully we get one this year. So Shirley wants to find an estimate for the number of bees in her hive. On Monday, she captures 90 of the bees, and she puts a mark on each bee and returns it to her hive. On Tuesday, she catches 120 of the bees, and she finds that 20 of the bees have been marked. Work out an estimate for the total number of bees. And this actually is how they count populations of things like dolphins, sharks, fish, etc. So here's how it works, okay? On Monday, when she catches 90 of the bees, she catches 90 out of the total number of bees in her hive, right? So she's got 90 of them out of however many there are in total. Cool. Then she releases them back into the hive, and then on the next day, she catches 120 bees and 20 of them are marked. Here's the logic. If I've captured this fraction of the bees, right, when I then take another 120 bees out, the fractions should be exactly identical. Okay? This might make sense if I actually put this in context. So let's say we have 90 bees, and that's out of, let's say, 270, right? And then when I capture, let's say, so that would be a third, so let's make it like 3 over 6. Let's say I capture 6 bees, right? And 3 of them are marked. The actual ratio, or the fraction, should be identical to each other, okay? Because it's equally likely that I get any of the bees, okay? So that's all you have to do. And then from there, all you're doing is just rearranging, right? So times both sides by n. I mean, you can do it however, whichever way you want, but that would be 90 over n equals, cross out the 2's, that'd be 1 over 6. So I'm going to move the n up by timesing both sides by n, which gives me 90 equals a sixth of n. Times both sides by 6. So here I just times both sides by n. Whoops. I get 90 times 6, so 9 times 6 would give me 54, so it'd be 540 for n. Okay. So these questions are very quick, and they're easy once you know how to do them, but hopefully that makes sense. All you do is you take the first number, 90, put it over n. You take the second number, the second set of numbers, and you put the number of markings over the number of that they caught, and then you rearrange. Simple as. 3 marks, pretty damn nifty. So she assumes that none of the marks have been rubbed off between Monday and Tuesday. If her assumption's wrong, explain what effect. So I want to point out quickly that usually they say, why is it an estimate? Or what assumptions have you made? And the assumption is always that none of the marks have been removed. That's always the assumption. It always gives you 1 mark. In this grade 9 version, they've told you that she assumed that. So what effect would it have? Well, the problem is if some of the marks have been removed, then this number here, 20, should have been bigger. Okay? So let me show you, right? Let's say instead of 20 over 120, it was 30 over 120, right? Again, this one is if like some of the marks have been rubbed off. So if they weren't rubbed off, there'd be more of them that have the marks, right? Then you would have 90 over n equals 3 over 12, which is a quarter. Move that over and you'd actually get a lower number of b's, right? You get 90 equals a quarter n. And so n is equal to 360. That is a lower number, okay? Again, you don't need to do any of this for the actual mark. I just wanted to show you so it makes a bit of sense. So what effect would it have? She would have overestimated the number of bees. Overestimated the number of bees. That's the effect it has. Okay. Hopefully that makes a bit more sense. I did kind of go into the explanation a bit deep there because I find that quite a few people aren't too sure about capture-recapture, but I hope that makes sense. For this question we have a straight line L1 has an equation of 3x minus 4, and there is a perpendicular line that passes through the point 9,5. Find an equation of the line. So if you want, I'm going to just quickly draw this out. So this is L1, and we have L2 that crosses at 90 degrees. So the first thing you should note is that the gradient of the perpendicular line is the negative reciprocal of the gradient of L1. So the gradient of L1 is 3, right? Which means the gradient of L2 is going to be the reciprocal, so 1 over 3, and then you change the sign. So if it's positive, it becomes negative, negative becomes positive. So now our equation for L2, again, we're going to be using y equals mx plus c for this, is just y is equal to negative a third x plus c, okay? Now, we need to work out what c is. Well, to work out c in any case, all you need is a coordinate. And in this case, we have 9, 5. So we're going to say that x is equal to 9, y equals 5. So we have 5 is equal to negative a third 9 plus c. So 5 is equal to, what's a third of 9? It's 3. Make it negative. Minus 3 plus c. which means if you add 3 to both sides, you get c is equal to 8. Okay. So my actual equation is minus a third x plus 8. Not too bad for 3 marks. Hopefully so far this paper hasn't been too bad for you. For this question, you could, if you want, do a probability tree. Okay, so Sally plays 2 games against Martin. In each game, Sally could win, draw, or lose. In each game they play, the probability that Sally will win is 0.3, and the probability that they will draw is 0.1. So work out the probability that Sally will win exactly one of the 2 games. It's 3 marks. So you can use a big probability tree, but it's going to be pretty big and complicated. So the next thing you can do is write down all the combinations, right? Now, here's where things can get a bit interesting when it comes to probability. So the probability she wins exactly 1, you might be right in saying, well, she could win and then lose, or she could lose then win, or she could win and then draw, or she could draw and then win. Yeah? Makes sense, right? She wins 1 in all of those. Exactly 1, don't forget. You could work out all of these probabilities and add them all up and you'd get the correct answer. So you're probably wondering why on earth I'm saying it this way. Well, there is actually another way of doing it, and this is the way that they show on the mark scheme as well. And you could say win and not win and win. And what's the probability that she doesn't win? Well, it's just the probability that she wins taken away from 1. So, there you have it. You can either do just these 2 sets of probabilities, or you can do all 4 of them and add them up. So what I'm going to do is I'm going to do it both ways, just so everyone is completely clear on what you can do. So, whoops, that was not what I was meant to do. There we go. Okay, so win and not win, you would just have probability of winning is 0.3, so 0.3, and then not win, so times 0.7, plus, not plus, because we're doing it on the next line, 0.7 not win times 0.3. So that equals 0.21, and that equals 0.21. So you'd add those together and you get 0.42, which is the correct answer, 3 marks, done deasy. But what we're going to do now is the other way that I told you about. Okay, so now we need to actually work out the probability of losing. So the probability she loses is 1 minus 0.3 plus 0.1. And that's 1 minus 0.4. So probability she actually loses is 0.6. So let's do this. And again, this is a much longer method, but just in case you weren't aware, like, you can do it this way, and I want to show you that you can get it that way. So you have 0.3 times 0.6. You have 0.6 times 0.3. You have 0.3 times 0.1. And then you have 0.1 times 0.3. So let's work all these out. 0.18, 0.18, 0.03, 0.03. Add these 2 together, you get 0.36. Add these 2 together, you get 0.06. Add those 2 together, you still get 0.42. So it's the exact same answer. Probability is a bit like vectors in that sense, where you can do the answers in multiple different ways and get the correct answer. And they're both equally correct. But I wanted to show you the mark scheme method because it is quicker, but I can imagine that some of you may have been a bit confused as to what the hell it's talking about. But you can do either way round. Okay? Just one of those 2 methods is perfectly fine. And for this question, we have 2 rectangles, A and B, and apparently the areas of them are equal. We need to find an expression for y in terms of w. So we want basically y equals and then a bunch of stuff that has w in it, okay? So let's work out the areas of A and B separately. So the area of A is going to be 6 times 2w plus y, right? Because that's how you work out area, it's just the 2 measurements times together. And that should be equal to 7w multiplied by 3y plus 6. Okay. Expand and simplify. We're going to have 12w plus 6y. So 6 times 2, yep, good. Equals 7 times 3 is 21 wy. And 7 times 6 is going to be 42 w. Okay. Cool. And now what we want to do is get y equals and then a bunch of stuff, right? So we need to do the same thing that we did in an earlier question. We want to move every term with y to one side and every term that doesn't have y to the other side. So I can see here that and that are my y's, right? So I'm going to move the 21wy to the left-hand side. So minus 21wy to move it over. And again, you can do it either way and you should get the same answer. So you get 12w plus 6y minus 21wy equals 42w. They haven't really given me much space for this. That's a bit annoying, but you know, it is what it is. Then move everything else, which is this 12w, to the right-hand side. So we're going to minus 12w on both sides. And we get 6y minus 21y, wy even, equals 42w minus 12w, which is 30w. Factorize out a y, you get y, open bracket 6 minus 21w equals 30w. So lastly, but certainly not least, you have y is equal to 30w over 6 minus 21w. If you put the w's and the y's on opposite sides to me, you're going to get the opposite signs. Okay, so you'd have minus 30w and you'd have minus 6 plus 21w. That is actually also the exact same thing and you get the full marks for it, okay? So just keep that in mind. If all of the signs are the opposite, that is totally and utterly a-okay. This question, we have a rationalizing the denominator question. And how do I know that? Well, whenever it gives you an equation that has surds in the bottom, you're going to be rationalizing anyway. And when I look at the answer, I see there's no surd in the bottom. So I'm definitely going to be rationalizing. And how do you do that? Well, you times the top and bottom by the exact same thing that's on the denominator, but you swap the sign around. So instead of 5 plus root 3w, you're going to have 5 minus root 3. Okay? So the top becomes 8 plus 12 in a square root times 5 minus root 3 over 5 plus root 3, 5 minus root 3. And then all we're going to do is expand the top and the bottom. Should be hopefully fairly easy, I'm hoping. But let's do it in fairly short, lengthy steps. 8 times 5 is going to be 40. 8 times minus root 3 is minus 8 root 3. Root 12 times 5 is 5 root 12. Root 12 times minus root 3 would be minus root 36, which you may know is just equal to 6. And that is over 5 times 5, which is 25, minus 5 root 3, plus 5 root 3. And then root 3 times root 3 is root 9, negative because it's a plus times a minus. And negative square root 9, what's the square root of 9? It's 3. So negative 3, take away 3. So let's work some of this out. We have, on the top, we have 40 minus 6, so that is 34. Now, root 12, I can write, in order to simplify, if you have a look, in our answer we just have root 3's. So I want to make root 12 into root 3. So think of two numbers, one of them is 3, that times to 12, but it's going to be root 4, root 3. So again, the way I got that is I know that one of the numbers has to be root 3. So root 3 times what gives me root 12? Root 4. And what is root 4? It's 2 root 3. So in other words, 5 root 12 is going to be 5 times bigger than this. So times it by 5, you get 10 root 3. So we have minus 8 root 3 plus 10 root 3, which is 2 root 3. Now you may notice there's no number in front of the root 3 here, but you know, just wait. I've got a feeling this is going to work out. And that's going to be over, well, these two things obviously cancel with each other. And 25 minus 3, get your calculators out, 22. So now, in order to get rid of the number in front of the root 3, that's a 2, right? So I want to divide everything by 2. And when I say everything, I mean every single term. 34 divided by 2 is 17. 2 divided by 2 is 1, so I'm not going to bother writing it. 22 divided by 2 is 11. That is our final answer for 4 marks. Again, Bit tedious, but it's not that bad once you get good at it. So I would recommend practicing these rationalizing questions, okay? This question was actually in the 2021 Edexcel paper one, I believe. And boy, is it a fun one. So there are 4 types of cards in a game. Each card has a black circle or a white circle, or a black triangle or a white triangle. The number of cards with a black shape to white shape is 3 to 5. So I'm going to write this information out. I'm going to call it BS to WS. I know it's an amazing way of putting it, I know. And then circle to triangle is 2 to 7, so C to T is this. And it says express the total number of cards with a black shape as a fraction of the total number of cards with a triangle. So we're doing 3, so this number here, over 7, right? No. Now here's where things get a bit spicy. In this type of question, it might say something like, Jack and Jill and Bill and Ted share the same number of sweets. You know, Bill to Ted, whatever, gets this ratio and the other two get another ratio. How many sweets are there in total? Something like that, right? That's the key point, is that if the total is the same, you can combine completely unrelated ratios. Okay, so you've probably seen one like this before. Again, where it's like 4 people share sweets. The ratio between 2 of them is this. The ratio between 2 of the other 2 is that. And it says work out the total number of sweets. And you think, what the hell? How do I do that? All you're doing is combining the ratio because the total number of sweets they shared is the same. In this case, can you see that if I add the black and the white shapes, I should get the same number as the circles plus the triangles, right? Because all shapes are either black or white, and all shapes are either circles or triangles. So in total, they should have the same number of parts, right? So if I add the number of parts for the BS to WS, that's 8. Add it for the circles to triangles, that's 9. So all I need to do is make these number of parts the same. Now the reason why we can't just say 3 over 7, by the way, is because the ratios have been simplified, right? And that's a problem because then they've been simplified by different amounts. One's probably been divided by, let's say, 4. The other one could have been divided by 3. So you can't put them over each other. They're not the same. So we need to kind of unsimplify them. And how do we make the number of parts the same? We find the lowest common multiple of 8 and 9. So the best way to do it is just times them by each other. So I'm going to times this whole ratio by 9 and this whole ratio by 8. 3 times 9 is 27. 9 times 5 is 45. 2 times 8 is 16. And 7 times 8 is 56. So now, this is actually all one big ratio. Black shape to white shape to circle to triangle is 27 to 45 to 16 to 56. So now I know that there were 27 black shape cards and there were 56 triangle cards. So the fraction is just 27 over 56. This is why the question is actually only 3 marks. Because I've only done 3 steps. Kind of 2 really. Okay? But a lot of people thought that this should be a lot higher. I will say that, again, since I've checked all of my answers with the mark scheme as well, the mark scheme way of doing this is disgusting. It doesn't make 100% sense in my opinion. Okay, and I can completely understand why some people might find that a bit tricky. Essentially, with the mark scheme answer, they say that black shapes are 3 out of 8 and triangle shapes are 7 out of 9. So if you express black shapes in terms of triangle shapes, is 3 over 8 divided by 7 over 9. So then you keep flip change and you get, so 3 over 8 times 9 over 7. So you get 3 times 9, which is, of course, 27 over 56. So it might be a bit faster, but in my experience, when I taught this question, a lot of students didn't understand this way, which is why I've done a different method. But if you understand this way, then good for you. And here we have yet another rationalizing the denominator question for some reason. And again, we're going to times by the denominator, but we're going to flip the sign in the middle. That's what we're going to times by. So let's just get to it. So we have square root. I mean, there is actually one thing I would like to do first. I'm looking ahead now. Square root 180 times kind of square root 5. That means I'm going to have to do 5 times 180, which it's not the hardest thing to do in the world. Bit annoying though. So I'm actually going to put this all in terms of root 5 now. So if I put this in terms of root 5, one of my numbers is root 5. What's the other one? Well, what is 180 divided by 5? Well, if you divide it by 10 and then double it, you'll get your answer. So divide by 10 is 18, double it is 36. So that's square root 36. So in other words, that is 6 root 5. So that's also another step I'm going to do kind of behind the scenes, so to speak. Because otherwise, I don't want numbers being big. They scare me. Root 5. And then we're going to times it by 5 root 5 plus 5 over 5 root 5 minus 5. 5 root 5 plus 5. Cool. Then we're going to expand. So 6 root 5 times 5 root 5. 6 times 5 is 30. And then root 5 times root 5 is 5. Don't forget. So that becomes 30 times 5. 6 root 5 times 5 is going to be plus 30 root 5. Good lord. So we've done those two now. So minus 2 root 5 times 5 root 5. So 2 times 5 becomes minus 10 because it's a negative. And then that's still going to be times 5 because root 5 times root 5 is 5. Minus 2 root 5 times 5 gives me minus 10 root 5. On the bottom you can be a bit cheeky. You know that the cross terms are going to cancel out, hopefully from the beginning of this video. So we just need to times this by this and this by this. But, you know, so 5 root 5 times 5 root 5, that's going to be 25 times 5. And then that'd be plus 25 root 5 minus 25 root 5 minus 25. Okay, so 30 times 5 is 150. So 3 times 5, add the 0. That is obviously 50. 25 times 5, so times it by 10 and then half it, so that'd be 125. And that's it. Okay, so we have 150 minus 50 on the numerator. 150 minus 50. So we're going to make that 100. Then we have 30 root 5 minus 10 root 5, so that's 20 root 5. All over, so obviously these two terms here cancel out with each other. 125 minus 25, which is 100. And now we're actually going to do the division, because if we look, the answer, it's not one big fraction, so it's been divided. So 100 divided by 100 is 1. 20 root 5 over 100, well, we can simplify that, right? 20 over 100, cancel a 0, so we get 2 out of 10. Divide top and bottom by 2, we get 1 over 5. So that becomes root 5 over 5. 4 marks, I actually think that's relatively generous. Not too bad. Some of the numbers are a bit big, but, you know, column method is king for that. For this question, it's kind of interesting. X proportional to the square root of y. So we're going to write x equal to k root y. In proportionality questions, just writing out the kind of expression, the equation, always gives you a mark. Guaranteed. 100%. So just do it, get a 1 out of 3. Easy. Y is increased by 44%, which means it's currently at 144% of its value, which as a decimal is 1.44. So we have x is equal to k square root 1.44. So all we need to do is work out what the square root of 1.44 is, and then we immediately get what the percentage increase is. We get the decimal multiplier. So how do I do the square root of 144, which I imagine some people may be a bit kind of nervous on? Well, I can make that. Can you see how those two lines are the same? Right? 1.44 is the same as 144 over 100. And I'm square rooting both of them. So, square root of 144 is 12. Square root of 100 is 10. So in other words, it equals 1.2. So x is equal to 1.2 times k. And what does 1.2 mean? It's 1.2 times bigger, right? So that's 120% of its original value. So the actual percentage increase is 20%, right? Because take away the original value, you get 20%. Nice and easy, hopefully. Actually, it wasn't very easy, but I hope that makes a bit more sense. So for this question, we have that there are only 3 red counters and 5 yellow counters in a bag. Jude takes at random 3 counters from the bag. Work out the probability that he takes exactly 1 red counter. So let's write down the possibilities. He could get a red and 2 yellows. He could get a yellow, red and a yellow. Or he could get a yellow, yellow, red. Correct? Now, here's kind of a little bit of a shortcut for you. All of these probabilities will be exactly the same. So we could just do one of them and times it by 3. But I'm going to go through all of it just to make it make 100% sense. So in total we have 8 counters, right? So probably getting a red first would be 3 out of a total of 8. Then he takes one red counter out, but the number of yellows is the same, so that'd be 5 out of 7. And then it'd be 4 out of 6, because he takes a yellow counter out and we're still asking for yellow. And that will equal something. And I'll show you at the end why they actually all add up to the same thing. So, yellow, red, yellow, we have 5 out of 8, because there's 5 yellow counters and 8 counters. We have the same number of red counters, so it's still 3, but there's 1 fewer total counters. And then we have 1 fewer yellow counters and 1 fewer overall. So if you notice, the numbers have just been jiggled around. But if you remember rightly, multiplication, the order doesn't matter, right? 5 times 3 is the same as 3 times 5. So all they've done is reorganized the numerator, right? The denominator is all the same, so it's definitely the same. But the numerator is just rejigged around. Okay, so you don't actually need to work it out in that sense. You don't need to work it out all separately. But again, that doesn't make too much sense. Good thing we're going to go through the whole thing anyways. Okay, so working this out is going to be fun. 3 times 5 is 15 times 4 would give me 120. What am I saying? It gives me 60. Sorry, I did the wrong one. It gives me 60. Anyways, then it would probably be what would it be best to start with? Probably doing the 8 times 7 would probably be the best. So that'd be 56. Then we're doing 56 times 6, which, yeah, it's not doing our heads. That's 36, 30, 336. And I'm hoping you believe me now that all of them are the same. And then all we're doing is adding them all up. So that gives me 180 over 336, which is the exact same as doing 3 times one of the probabilities anyway. But yeah, that would be the full 4 marks. Again, I think that's relatively generous. Probability, you just need to kind of write out all the combinations and then work out the probability for each. Add them all up, generally speaking. Hey, look, it's vectors, everyone's least favourite topic, I think. Except mine, I love this topic. DEF is a triangle. P is the midpoint of FD, and Q is the midpoint of DE. And we have FD is equal to A, so the first thing I would actually start doing is labelling up this diagram. And FE is B, so this thing here is B. And we're trying to prove that PQ, so this line here, is parallel to this line. And how can we do that? Well, what does it mean when something's parallel? Well, what it means is that PQ can be written as a fraction or as a multiple of FE. That's what that means, okay? So we should be able to write PQ in terms of FE, okay? So what we're going to do, and in this case, by the way, FE is just B. So in other words, PQ should be able to be written as K, where K is an integer, times B. Okay, well, let's work out an actual equation for PQ. And there's a bunch of different ways to do this. You could go, and if you go a different direction to me, that's totally fine. We could go from P, let's do it in like a green color. We could go from P to D and then D to Q. So, okay, let's write that down. We've got P to D and then D to Q. Right? Just following the lines. PD, well, P is half of FD, right? It's the midpoint. So it's half A. And what about D to Q? Well, D to Q is a half of DE. So now what I need to do is work out what DE is. Okay, so I need to work out what DE is. So remember, one of the rules of vectors is that you can only go along vectors that you actually know, right? So I'm going to write out, just going to set myself up for a sec, and we're going to work out DE. So I can't go straight down here. So instead, I'm going to go back to F and then along to E. So that would be minus A, right? And why is it minus? Because I'm going in the opposite direction to the arrow, right? If I wanted to do this, I would have to go against it. And then I'm going along B, so it'd be plus B. So that should equal half A minus a half A is 0A, and then it'd be a half B. Well, if you notice, PQ is just a half B, and that does equal KB, where K is equal to a half. Right? So in other words, PQ is a half of FE. Therefore, they are parallel to one another. Okay? So you do have to write some kind of conclusion. So this is actually good enough for your conclusion. But for those of you that are paranoid like I am, I will just say, therefore, PQ parallel to FE. Okay, just indulge that paranoia in terms of maths. For those of you that watched my recent kind of inequalities video, you should hopefully be very good with this question, right? We need to essentially write out all of these inequalities on this and shade the region that satisfies all of them. As for why they gave such a big gap here, I don't know, but let's do it. So let's start with the easiest one, which is probably going to be x is 3. Now, it says less than, and it's not equal to, so it's going to be a dotted line. So let's have a look-see, shall we? So we find 3, x equals 3 would be a vertical line, right? Because that's where x equals 3. Draw a big old dotted line like this. So that one's done, okay? So again, if we look at the marks, 3 marks, we are gaining marks as we speak. Now for this one, this is pretty good. Again, it's less than, not equal to, which means it's going to be a dotted line. And if we look, it says it crosses, the y-intercept is 6, let's put a line here. And then this minus 3 means for every 1 to the right I go, I need to go 3 down. So 1 to the right, 3 down would be 3, 1 to the right, 3 down would be 0, and then we can keep going, 1 to the right, 3 down. And please keep in mind that you should use a ruler for this, because mine's not going to be perfectly straight. Cool, that one's done. I would recommend labeling your lines too, just to make the examiner's life that bit easier. I know you may not like the examiner, but you need him or her to have the best time possible when marking your paper, just so they're not grumpy. For this one, we actually need to do a little bit of legwork. We need to rearrange it so it's y is less than a bunch of stuff. So I'm going to move the 4 over, so we get 2y less than x minus 4. Divide both sides by 2, you get a half x minus 2. So what this is saying is, and again, it's less than, not equal to, so we're doing a dotted line. If it is equal to, you use a solid line. Minus 2, so let's put a little x there. And then what this is telling me is every 1 to the right I go, I only go half a square up. So in other words, I have to go 2 to the right to go 1 up. 2 to the right, 1 up. 2 to the right, 1 up. Whoops. And then we're just going to draw a dotted line. Again, ideally with a ruler. And it's going to be 2 to the right, 1 down. So it's going to be 2 to the right, 1 down. And let's label that line as a half x minus 2. So we've now got 2 of the 3 marks. Again, that's actually a bit harsh. I would have thought this would be 4 marks, but, you know, don't call it grade 9 for nothing. And we're trying to label the region that is less than all of these lines. So if it's less than x equals 3, it means it's going to be on the left-hand side of this line, right? Left-hand side of x equals 3. So somewhere over yonder. It's going to be below this line here. Okay? And it's also going to be below this line. So the only region that actually satisfies that kind of criteria is actually this region here. Right? Now again, some people have said, oh, it's just the shape it makes, right? Like the little triangle, haha, right? Most of the time they do make it just the triangle underneath, but as this question shows, they can make it any region on this diagram. So don't just label like the triangle or the square that it makes, okay? Because that's not necessarily correct. For this question, we have a trapezium A, B, C, D, and the area is 66 centimeters squared. The length from A to B, and the ratio from D to C is going to be 2 to 3. So basically, A to B is 2/5 of C to D. Find the length of AB. Well, that's fun. So let's write out the information they've given us, okay? So first things first, the area of the trapezium is 66 centimeters squared. So what is the area of a trapezium? Well, it's a half A plus B times H. And we know that that equals 66. The next thing they give me is that the length of AB to the length of CD is 2 to 3. So the way I'm going to write this is if I say that the total length, right, so this ratio, the total parts, so 5 parts, equals x, which is some length, then that means AB, so wait, 1 part is equal to 1/5 of x, then that means AB is 2/5 of x, and BC is 3/5 of x. Okay? So now that gives me just one unknown for this a plus b bit. The only other unknown I have is h. Well, if I look, they've also given me an angle. And again, remember, they never give you information they don't intend on you using. So what we're going to do is, I want the height, which is the vertical height. That's height. But if you look, it's actually the same as that. Now we have an angle, a side, and we want the third side, and this is indeed a right angle triangle. We're going to be using trigonometry. So this tells me that sine theta, that's my opposite side, so equals h over the hypotenuse 6. So h is equal to 6 sine theta, 30. And what is sine 30 again? It's a half. So h is equal to 3. So again, this 0.5. So now I can sub all of this into my equation and hopefully have a decent time. So a is 2/5 x plus 3/5 x times the height, which was 3, equals 66. So what I'm going to do, this is a pretty big brain move, is the first thing I'm going to do is, before I get rid of, kind of expand the brackets, I'm actually just going to divide both sides by 3. So that's a half. 3 over 5 plus 2 over 5 would just give me just x equals 22. Times both sides by 2 to get rid of the half, we get x is equal to 44. Okay? Now, we should see that the length of AB is 2/5 of 44, right? So all we need to do for AB is take 2/5 of 44. I know I've said that over and over again. It's making it lose meaning for me. So that would be 88 over 5, which divide by 10 would give me 8.8. Double it gives me 17.6 centimeters. 5 marks? That's not that bad, to be honest. Honestly, it's a very tricky question, but the length actually wasn't that bad. For this question, we have some functions. We have f of x is 3x squared plus 1, and g of x is 4 over x squared, and we want to work out gf of 1. So what does this mean? Well, it means we're going to work out f of 1, and then take that answer, and then sub it into g. So 1 squared is 1, times 3 is 3, that equals 4. So now g of 4 is just equal to 4 over 4 squared. So we can actually cancel out a 4 on that, which gives me 1 over 4. The other way you could do it is it would be 4 over 16, which cancels down to a quarter, right? But, potato, potato. The function h is such that h is equal to the inverse function of fg. So what we need to do is work out fg of x and then work out the inverse function. So this means we're going to take all of g of x and sub it into f of x. So that becomes 3, then all of g of x, which is 4 over x squared, to the power of 2, plus 1. So that becomes 3 times 4 squared is 16 over x to the 4 plus 1. So that becomes 48 over x to the 4 plus 1. And that's fg of x. Now to find the inverse function, what we're going to do is we're going to write y equals 48 over x to the 4 plus 1. And we're going to rearrange for x. And minus 1 from both sides, we get y minus 1 is equal to 48 over x to the 4, times both sides by x to the 4, we get x to the 4, y minus 1 equals 48. Then we're going to divide both sides by y minus 1, we get x to the 4 equals 48 over y minus 1. Take the fourth root, and that means the inverse function is the fourth root of over y minus 1. So therefore, that is equal to h of x. Okay? And that would be it for the question. Well, I mean, actually, what we need to do, one thing. We need to replace y with x, of course. In this question we have a graph, more likely a circle, of x squared plus y squared is 30.25. And we need to find estimates for solutions of the simultaneous equations using the graph. So what we need to do is actually draw this graph on here and see where they intersect. You should get two pairs of coordinates which will give you two x values and two y values. So we need to rearrange this to give us y is equal to 2x plus 1, and then let's plot that graph. So it crosses at 1, and then every 1 to the right it goes 2 up. So let's do this, and like I said, the actual mechanics of me doing this is interesting. So you know what? It's time. It's time. We need to actually whip out the ruler. All right, this thing is a bit of a pain in the neck to use, but let's go a bit in. Now it seems too steep. Okay, let's draw something like that. Okay, now I need to shove this off into the corner so it doesn't look at me. And all we're doing is looking at the points where it intersects. So we have this coordinate here, which is 2.1, and let's call it 5. So one value is x equals 2.1. Y equals 5, and it gives you a range of 2 to 2.2 and 5 to 5.2, so that's fine. And then we have this one over here, that is, I'm going to call it negative 4.9, 4.8 even. And what is the x value? Let's call that, now that is minus 2.9 for sure. Those are your answers, okay? So it's a relatively quick thing to do. It's just, you know, straining your eyes trying to stare at the screen, looking at it is a bit of a challenge. But obviously that won't be a challenge in the exam because it won't be on the screen probably. Anyways, for the next question. Whenever you see a question that says find the coordinates of the turning point on the curve with equation whatever, you should think immediately of completing the square. Now, there is a problem here. And I'm just going to rewrite this in order of descending powers of x because I want to. And that's that the completing the square formula that I've shown a few times before, which is this. And then you have, you know, bear with me, this does take a bit of time. If you notice, it doesn't have anything in front of the x squared. So what we're going to do is factorize it out, right? Minus 3. Open bracket, we get x squared minus 6x, because all of these signs have now flipped, right, because we factorized out a negative sign. Now we do completing the square. So minus 3, I'm going to use staple brackets now, because we're going to have x minus 3 squared minus 3 squared minus 3. Jesus Christ. Minus 3, x minus 3 squared. That'd be minus 9 minus another 3 would be minus 12. Then we're going to expand the brackets, which gives us minus 3 x minus 3 squared plus 36. Now, to actually get the coordinates of the turning point is really, really easy. You take the number on the inside of the brackets and you flip its sign. So it goes from minus 3 to plus 3, and then you just take this value and you shove it on the end. Plus, minus, doesn't matter. You put, if it's minus 36, you put minus 36. If it's plus, you just put 36. Okay? And I've explained how this works in my completing the square video, so if you want a kind of deeper understanding of how completing the square works and why it gives you the turning point, I'd recommend looking at that video. But without further ado, we're going to move on to the last question of the paper, and then we'll be finished. So I think so far this paper hasn't actually been too bad. I think it's been the easiest of the kind of grade 9 papers that we've done, of the 3 that we've done. However, this is where it gets a bit spicy. So we have two shaded shapes A and B, and it tells you that A is formed by taking this big sector and minusing the small sector from it, and then obviously the shape B is just a circle, right? So how do I work out the area of a pizza slice? Well, a pizza slice is just a fraction of a pizza, right? Of a full circle. So all I need to do is work out what fraction it is. And the way you work out what fraction it is you take the angle subtended by it and divide it by 360. That gives you the fraction of the full circle that you have. So if we write this out now, we're going to have 45 over 360 pi, and what's the radius of the overall big pizza slice? Well, it's 5x, so 3x minus 1 plus 2x, 5x minus 1 squared, minus the small pizza slice, 360, which is pi, and then times 3x minus 1 squared. And that should equal the area of the circle, which, if you just half this, that gives you the radius, so it would be pi times 1 minus x. Now I'm going to cancel out all the pi's because I want to, and 45 over 360 is going to be a bit annoying, so I'm going to cancel it down. 45 does go into 360, so 45 doubles to 90, doubles to 180, doubles again to give 8, so it gives 360. So in other words, all of this is actually just an eighth 5x minus 1 squared minus an eighth 3x minus 1 squared equals 1 minus x. Okay. And then what I'm going to do is I'm going to times everything by 8 because I don't like fractions. And then obviously this is squared, by the way. I neglected to write that. So let's get to it. So 5x, let's expand it. 5x times 5x is 25x squared. Minus 5x minus 5x is minus 10x. That's 1. Minus 9x squared. Minus 3x minus 3x is minus 6x. Plus 1. Equals 8. X squared minus 2x plus 1. Okay. Expand the brackets and simplify. So 25x squared minus 9x squared would give me 16x squared. And then minus 10x minus minus 6x would give me minus 4x because it'd be minus 10 plus 6. And then 1 minus 1 gives me 0. Okay. And that should equal 8x squared minus 16x plus 8. Now what I want to do is actually move everything over to the left hand side because to solve quadratics you need to make it equal to 0. So that would give me 8x squared because I'm going to do 16x squared minus 8x squared minus 4x plus 16x would give me plus 12x. And then that would be minus 8 equals 0. I'm going to divide everything by 4 to make my equation a bit nicer. So that's 2x squared plus 3x minus 2 equals 0. Then all you want to do is factorize using whatever method best suits you. So you can kind of find two numbers that times to minus 4 and add to 3 or whatever. However, I can actually factorize in my head. So just in the interest of time, let's factorize that. So either x is equal to a half or x is equal to minus 2. Now, of course, it equals to a half because remember, x is a length. So it has to be positive. And that brings us to the end of the Set 2 Grade 9 Paper 1 questions, right in time for the exam. So hopefully that's useful. Again, if you have any questions about the methods I've used, please leave them in the comments and I'll do my best to kind of get back to you on that. But otherwise, best of luck with your revision. A few more days till the exam. Let's get cracking.